If you ask two different language models to define a single word, they might give you the exact same text output, but mathematically, they process that shared vocabulary in complete isolation from one another. When a standard model ingests a word token, it maps it to a dense mathematical vector in a high-dimensional space. This diagram shows two different vector spaces. Notice how the same token, the word banco, maps to completely different coordinates in each space. The resulting embedding is a private artifact. It is the unrecoverable residue of that specific model's unique training history and millions of localized parameters. Because the geometries are totally isolated, dimension 500 in Model A does not equal dimension 500 in Model B. They speak entirely different mathematical dialects. The consequence is that a receiving model cannot look at an incoming embedding and reverse engineer why the vector has those specific values. These systems can easily exchange raw text or final data outputs over an API, but they cannot directly exchange the logical process that led to those outputs. Modern AI is trapped in an architectural blind spot. Systems can simulate understanding exceptionally well, but they cannot natively exchange verifiable epistemological logic. Aurora replaces arbitrary weights with reproducible universal resolutions. It abandons continuous private floating point vectors in favor of a strictly bounded, discrete ternary structure. Notice how the structure normalizes across these simulated nodes. Every single token in the Aurora architecture, universally across all nodes, uses this exact same 81-trit shape. This creates a universal base vocabulary. A simple tensor operating in node A is mathematically identical in structure to the same tensor in node B. All nodes execute the exact same deterministic operator on these base units. Replacing private embeddings with canonical tensors gives these systems a common mathematical language for direct interaction. Aurora's base unit is the trait, holding a value of 0, 1, or 2. These units organize into a strict fractal hierarchy. They branch from 3 to 9 to 27, completing the 81-trait grid. This grid is the absolute physical limit of the tensor's shape. It never grows wider or deeper in dimensions. How can a rigid, finite structure map the infinite conceptual complexity required for advanced logic? If Aurora relied exclusively on this physical array, information loss would be catastrophic. The physical shape is only half of the tensor's identity. An Aurora tensor functions as an active operational state machine. It pairs with a metadata triad, DS for synthesis, DE for state, and DO for provenance. The value 2 inside the tensor is uniquely powerful here because its meaning depends entirely on that DE, or state variable. On the left, a closed state means 2 is a resolved terminal value. On the right, an open state acts as a pointer. This DO, or provenance function, allows the system to descend through the portal to recover the specific generating components. Because the synthesis operator is deterministic, the system doesn't need to permanently store the entire logical domain in the top-level tensor. Nodes operate on a fast, highly compressed value plane. Deeper domain planes recalculate on demand. Complexity in Aurora is not achieved by infinitely expanding the tensor's size, but by securing an exact, traceable descent into provenance. In this framework, compression means discovering a coherent, reusable logical organization. When a node finds a coherent relationship between 3 base units, it passes them through the synthesis operator. The output is a new tensor mathematically representing its parents. Notice this new tensor is perfectly identical in its 81-trit shape to the inputs. This property is autosimilarity. The output of one level becomes the structurally identical input of the next. This allows the local dictionary of a node to grow fractally, storing crystallized logical resolutions instead of just a static vocabulary. The structural uniformity guarantees that no matter how complex an idea becomes, it can always be contained and transmitted in the universal base format. Standard architectures require a central authority to broadcast massive network-wide weight updates. Aurora does not. The network is entirely conversational. A node only asks the broader network for help when it encounters an open state, an E equals 2, that it cannot resolve locally. When another node answers that query, the receiving node gets a strict mathematical payload. The payload contains 3 components: the proposed synthesis, TC, its precise provenance, pi c, and the measured evidence, epsilon c, behind it. providing an answer alone is insufficient. The network mandates that a hypothesis travel with the explicit evidence of its logical closure. Nodes act as independent epistemological agents, querying the network strictly on demand to patch specific structural blind spots without absorbing irrelevant data. How does a node know the provided payload isn't just a hallucination from a flawed neighbor? Through independent recalculation. The receiving node extracts the provenance roots, runs them through its own local universal operator, and checks if the output matches the provided synthesis. The network requires perfect parity. This enforces a rigid architectural maxim: to verify is to re-execute. It creates a permanent divide between an abduction, a locally generated unverified hypothesis, and a crystallization, a truth mathematically confirmed by external independent re-execution. By explicitly forcing nodes to show their work, the system protects itself from auto-poisoning and recursive feedback loops. The Aurora model discards the opaque, private memory of localized weights. It replaces them with a distributed, evolutionary network built entirely on reproducible logic.